Okay, the way that these inverses are used has to do with solving for an unknown. How do I solve for x?
Divide by 3.
I divide by 3. Okay, so no problem, then I easily find x is equal to 4. All right, I'm going to do that same concept with a matrix. Let's say I have this equation. Well, that doesn't look like a matrix to me. So the first thing I got to do is I got to put it in matrix form. Well, matrix form is really easy. All I do is I go 3, -2, 4, and 1. Now these are all the coefficients. 3, -2, 4, and 1. And I put them in those same positions, okay? It's like I take this and I just bring down the coefficients. But I'm going to multiply these by x and y. And you're going, what? Well, see, this is the same as that. Think about multiplication, row by column. 3 times x plus -2 times y. Isn't that what I have up here? 4 times x plus 1 times y. Oh, that's what I have here. What is it equal to? It's equal to 7 and 8. Okay, that's a matrix form of those equations. Okay, not hard to put it in there. If they tell you to put those two equations in matrix form, that's what it's talking about. Okay, now, how do I solve it? Remember this? What did I do? I divided. Okay, well, I can't really divide by a matrix.
Multiplied by the inverse.
That I'm multiplying it by the inverse, which is the same thing I could have done right here, because remember, when you divide, you invert and multiply. So this is the same thing as saying, oh, I'm not going to do 12 divided by 3, I'm going to do 12 times 1/3. That's the inverse of that. So what I can do is I can go, well, I'm going to take x, y to solve for that, and I'm going to multiply, I'm going to have it equal the inverse of this times that, okay? Now I can't do it the other way around. I can't do this times the inverse of that. Remember, there's order to multiplication. What are the dimensions of the inverse of this?
2 by 2.
It's a 2 by 2. Now, think about it. A 2 by, if I'm going to try and multiply, and I'll do the x, 2 by 2 by, and what are the dimensions of this?
2 by 1.
2 by 1. That's the only order I can do it in. I can't switch and say a 2 by 1 times a 2 by 2. Remember, those center terms have to match. And if I try to do this times the inverse of that, which is what this is, do those center terms match? No, so order is important. I have to do the inverse of this times that, which is what this top one is. Okay, you with me? All right, so, wait, I did that and then I forgot to set my timer. All right, so I'm going to take the inverse of this, okay, which is 1 over the determinant of this, which is 3, 4, -2, and 1. And I'm going to multiply it by, remember, I have to switch these two. So 1 and 3, I have to take the opposite of those two. And I get that. Times 7 and 8. You with me so far? Okay, now I'm going to go ahead and do the determinant here. So I have a 3, because I'm multiplying up, minus a -8. So that's going to give me 1 over 11. Would you agree with that? Okay, so I'm going to go ahead and mark that out, and I'll put an 11 there. Okay, so I've got 1 over 11, then I'm going to multiply it by this. Now, if you want to complicate your life, you can go ahead and do scalar multiplication here. I don't want to complicate my life. Okay, so I'm going to multiply these two things first. Then I'm going to take the answer and I'm going to multiply it by 1/11. I don't want to work with all those fractions. Okay, you with me? All right, so I'm going to come up here because I'm running out of space. Okay, now remember, multiplication, row by column. So I've got 1 times 7 plus 2 times 8. Okay, now remember I got 1/11th right here too. Okay, I've got 4 times 7, which is negative 28, plus 3 times 8, which is 24. Okay, so I have 1/11th times, that's going to give me a 23, and then on the bottom I'm going to have a negative 4. You with me so far? So I have, when I multiply that, I'm going to have 23/11 and negative 4/11. What is that? What is it? Well, what do I still have left? I still, on the other side, have my x and my y. So guess what? X is equal to 23/11. Y is equal to negative 4/11. Now I could have done this with elimination. I could have done it with substitution. I could have even done it with Kramer's rule. Okay? But this works this way. Now this seems like you're going, why would I want to go to all that work? Okay, well I'm going to show you on a 3x3 why it's not work. When I have to do it by hand, it feels like work. When I do it on the calculator, it doesn't feel like work. Okay? Let's do a 3x3. Okay? And I'm going to show you how quickly, yes,
Can I go to the
sure, absolutely. It'll take me probably that long to get it written up here. I'm going to show you how quickly it can be done on a calculator. All right, let's say I have this equation. All right, we'll wait for Reagan to get back to work on this. You have a calculator? Everybody's got a calculator? Okay. If you can figure it out, go ahead and start putting it in matrix form in your calculator. Okay, so you're going to do this in matrix form first. What's your coefficient here?
0.
0. So you can fill this in as like plus 0b, okay? So that you have a 0 coefficient there. Okay, so put it in the matrix form. So you have a 3, a negative 5, a 2, a 4, a 7, a 1, a 2, a 0, a negative 1. Okay, so you need to get that matrix into your calculator, put it in under A, okay? So put this one in under matrix A, put this one in under matrix B. Okay? You have your calculator, Reagan?
I've left at home.
Okay.
It's a decimal.
Is it a decimal?
Mhm.
Convert it back. Well, and I'm not surprised because they were only really using these to show you how to put it in matrix forms. They weren't having you solve it. Will it convert back to a fraction, Joseph? Okay, did you get this one in?
Mm-hmm.
Did you get that one in?
And you'll be done.
Does it?
Yeah,
Okay.
it's a big fraction.
Oh, it's a big fraction, so it really doesn't matter. Okay, so put this in as A, put this in as B. You're not doing anything to this. Okay?
And then you want me to?
Hold on. We'll let Reagan get caught up here, and then we'll go from there.
so multiply.
Okay. Yeah, now to solve this, okay, now remember, I gotta get rid of this. Okay, it's gotta go to the other side. To take it to the other side, I'm taking the inverse. So in my calculator, all I do is I select matrix A, and then I hit that, x to the negative first power, times matrix B. Hit enter, and then convert it back to fractions. Okay, Joseph's already told us it's big fractions, because see, this was a problem that the book really didn't want you to solve, but, yeah, we'll do it anyway. Okay. Joseph, tell me,
It's 306 over 79.
306 over 79?
Mm-hmm.
Okay. B,
Negative 93 over 79.
okay, C,
Negative 336 over 79.
okay. Now, can you imagine having to figure that out by hand? Okay, by elimination, or I'm like, that would not be fun. Okay, did you get it? It is so quick and so easy to do this way. Remember those pages where we took the whole page to try and find A, B, and C? It's such an easier way to do that. All right, we're gonna do one that actually comes out even, that's a 3 by 3, okay? In other words, it's gonna have 3 terms to it.
So you can only do this by a 3 by 3?
No, you can
Okay.
do any,
That way.
you can solve, but we're gonna do a 3 by 3, then we'll come back to a 2 by 2. Okay, but since you're on the mode and that's the dimensions that you have in your calculator, hold on, give me a second, let me go back to where we were doing 3 by 3s. Okay, and I'll try and do one that comes out even. Okay, let's try this one. So the very first thing is putting it in matrix form. Then once you, and you can do that as you're putting it in the calculator. I mean, you don't have to write anything down. Look at this one. Okay, solve this one for me, using your calculator. You get it? Vivian, you get it? Okay, you should have 4, 11, and negative 8. No. Okay, let me see it.
I don't know if I just didn't multiply. I think I plugged everything in right.
You didn't take the inverse today.
Oh, okay.
Okay, so if I select matrix A, and then I hit this inverse button, times, and then I go back and I select matrix B. There you go. You just forgot to take the inverse of it. Do you see how quick that is? Okay, now when you go to take the SAT, the ACT, and they give you a problem like this to do, if you did it by hand, the way that we did it before, where you did elimination and narrowed it down to 2 equations, put it together, you're talking that's going to be a lot of time. Versus just, you'll have your calculator in front of you, versus putting it in matrix form and doing it that way, you're going to save several minutes that you could be working on another problem. Okay? All right. All right. I'm going to give you one to try and do by hand, though, without using it. Yeah, I know. That's no fun. Okay. Don't use your calculator on this, but I want you to solve it by hand. Okay? It is going to come out whole. okay, which should help a little bit. So in other words, what you're doing is you're finding the inverse by hand. So it's gonna be, you're gonna find two things. You're gonna find the x and the y. Oops, that's a. Okay. Solve for x and y. Not using elimination or substitution, but using matrices. Did it click?
I heard like a beep.
Shut it still. When you hear it really click, let me know, because I forgot to set my thing in the beginning. And remember, I said it comes out even, so take the time to divide it. Oops, something's wrong there. I started looking at that as 37 rather than a negative 3 and a 7. So what you got?
Mm-hmm.
For some reason, this